All right, let's look at number 4 real quick. So right here it says for the rose curve r equals 2 cosine of 9 theta. Where's the first petal located? Give the smallest angle in degrees in the interval between 0 inclusive and 360 non-inclusive. And so I see you put 40, and I could see why maybe you would do that. But right here we're including 0 as a potential value, and so cosine's petal always starts at 0, so that's why we have 0 as our answer. 0, or you could have put 0 0.0. Either one would have been counted correct. And then from there, you take 360 and divide that by the coefficient of theta, and that'll give us the how many degrees you need to rotate per rose curve. And so that's where I'm assuming you got your 40 from. And so just kind of be careful. So if it would have asked you where did the third rose curve start, it would have been at 80 degrees because the first one was at 0, then we go 40, and then 80, and so on. So I don't know, maybe you might have just overlooked that 0 is part of my parameters. Okay, the next three are kind of similar. The first one's not too bad, and then they do get a little complicated after that. But right here it says the graph r equals 6 plus 6 times sine of theta passes through the pole when theta equals what? And they want our solution to be somewhere between 0 and 360 and 1 decimal place. All right. So uh, basically, if you're going to pass through the pole, your radius is going to equal 0. And so that's what we're going to have to do, set r equal to 0. So we're going to have 0 equals 6 plus 6 times sine of theta. And so let's see, we'll subtract 6. Negative 6 equals 6 times sine of theta. Then we'll divide by 6 on both sides, and we'll get sine of theta equals negative 1. Well, sine of theta will only equal negative 1 at an angle of 270 degrees. So at 270 degrees, sine of theta equals negative 1. And so see, if you were to plug it back in, this would become negative 1, which would turn this to negative 6. 6 plus negative 6, hence you get the 0 value for r. So the next two are going to be done the same way, but they are definitely a little bit more complicated in kind of thinking this through. So, but it's going to be the same idea. We're going to let r equal 0 and set it equal, or I'm sorry, yeah, let r equal 0 and go ahead and solve it from there. Sorry. Okay, so here we go. So we're going to subtract by 3 on both sides to get started. And so we'll cancel that out. And so we'll have negative 3 equals 7 times cosine of theta. And then divide by 7 on both sides. And so I'm going to come up here. So then we're going to have cosine of theta is, oh yeah, that's a negative 7. Let me fix that real quick. Let's see, so that was, because that was minus. Okay, so we're dividing by negative 7. So, okay, sorry about that. So a negative divided by a negative, we're going to get positive. So that's going to be positive 3 over 7. Okay, so what's different about this one and the previous one is that there's actually two different angles that will give you a cosine value of 3/7. And so I'm just going to do kind of a little bit of a rough sketch of that. So it's probably, let's see, I'm going to try to get these straight. So that would mean my x value is about 3/7. And so probably something like that, somewhere up there, and then somewhere down here, right there. And so um, we're looking for this angle right there that creates this, and then we're also looking for the angle that goes all the way around right there, because that cosine value is the length of x right here that lines up with the endpoints of these lines that I drew for my angles for my terminal sides. So that's that's what this value is right there, 3/7. So we are going to put it in the calculator. And so let's see. Let's see. Take the inverse of 3/7. And And so we get 64.2. So that would be this inside angle right here. So 64, what do we say? 64.6, yes. Okay, so that's the first angle. And then, let me erase this right here. So that angle going up is the same as this angle going down right here, except it would be negative, right? 64.6. But the problem is, they want my answer to be between positive 0 and positive 360. So we don't want any negative results. And so, and I see that you actually put that as your answer right here. You just were off on the rounding. You just went around 1 decimal place. But basically what you can do in your calculator here is take 360 degrees and subtract off 64.6, and that's where I'm getting the 295.4. So 295.4. So there's my two angles that will give me that ratio for cosine. And so see if this is negative 64.6 because a full rotation is 360, but then I subtract off that 64.6 and it puts me right there, and that's how I figured out that angle of 295.4. Okay, let's try the other one. The other one should be pretty similar. I think we're dealing with sine though instead, but other than that, it's going to be a pretty similar process, and it looks like once again you got one of them, we're just missing the other one. So we'll go ahead and set this equal to 0. So let's see, 4 plus 9 times sine of theta. And we'll go ahead and subtract by 4 on both sides. And let's see, 9 times sine of theta. Or, yes. And then we'll go ahead and divide by 9 on both sides. Pull this up over here. So let's see, we're going to have sine of theta is equal to negative 4/9. Okay, so once again, might be helpful just to kind of draw a little picture of what's taking place here. So sine is negative in quadrants 3 and 4, and so I'm just going to try to kind of estimate this the best I can, but let's see, down, it's a little bit more than halfway of my x distance, so about right there. It doesn't have to be perfect, it just kind of can be a little helpful in trying to figure out these angles. So what we're going to do is we'll go ahead and put it in the calculator, and it's going to give me this angle right here. It's going to give me a negative angle right there. So let's go ahead and put that in and figure out what that is and go from there. So let's see, sine inverse of negative 4/9 is negative 26.4. And so what I can do is, and I guess I could have mentioned this on the last problem. I mean, this is what we did anyways, but I'm basically going to add 360, and it's going to cause me to go around and be coterminal with that. But what it will do is give me the angle as though I'm starting in my initial position right here. So I'm going to go ahead and add 360 to this. And so that's where our 333.6 comes in from. So right here, that's where we're getting this. Okay, now on the other end, what's going on is that angle is the same angle right here coming down right here. That's 26.4 degrees from here to here. And we know that this is 180 from here to here. So we'll just add 180 and 26.4. And when you do that, you get 206.4. And so that's my other angle that will get me in that same position right there. So I hope that's helpful. And, if any others pop up, just shoot me an email and I'll send you a video.